Hi, I'm Aman Mathur. 3D printing and local manufacturing has become increasingly important of late. The enabling technology, of course, is computer aided design or CAD. We make an object once and then change parameter values to get infinitely many variants. We at the Max Planck Institute for Software Systems have made an interesting contribution at how we interface with CAD, and I'm here to talk more about it. Now, almost everything we own today was first conceived in a CAD software. Parametric CAD is quite a big industry in itself. The kind of objects we focus on here are regular shaped everyday objects like these. Professionals and enthusiasts have already been 3D printing such objects for a while, but recent supply chain shortages have renewed a broad interest in the field. There are already some popular websites, such as Thingiverse, where users from all over the world share, customize, and download each other's designs. Thingiverse's online customizer enables end users to change parameters of some designs, and people can get tailor made final objects. So, before we proceed, how do we design these objects? What are the interfaces we're talking about? There are, of course, GUI-based interfaces such as Fusion 360, Onshape, and FreeCAD, which is an open source alternative. These are very simple to use and extremely popular. Then, with an almost divergent philosophy, we have programmatic interfaces. OpenSCAD is popular with Thingiverse users. There's also OpenCascade, which is a large and versatile CAD library. And there is CAD Query, which is a domain-specific language based on top of OpenCascade. Now, as you may imagine, neither interface is perfect. We will be coming back to this very soon, but at a high level, GUI-based interfaces make brittle designs. However, they're extremely easy to use, learn, and they're very intuitive. Programming, on the other hand, makes robust designs, but programming is difficult. Now, designers have traditionally chosen one interface and have had to deal with the shortcomings of their choice. And this is where we come in. We bridge these two interfaces together so as to offer designers the best of both worlds. Now, before we proceed, I'd like to acknowledge that the ongoing pandemic has affected us all. We can all agree that it has shown us how valuable the simplest of things in our life are. This roll of toilet paper, for example. I'm going to show you what is perhaps the biggest limitation of GUI using this humble roll. We're going to be designing a toilet paper holder in FreeCAD, which is GUI based. So first we make a base. This is a rectangular base. We give it the correct dimensions here. And there we have it. Next, we make a cylinder. It's very small right now, but we're going to increase the radius and give it a bigger height. Next, we place the cylinder on the center of the base on top of it. There we have it. We want one final object, so we union the cylinder and the base. Next, we select this edge here, which connects the base to the cylinder, and we fillet it. We want a smooth edge here, essentially. And there we have it, our toilet paper holder in GUI. This looks nice, but it isn't quite usable for me at least. I have some space constraints and this base is far too large for me. Well, this isn't a problem, right? This is parametric CAD, so I can go back, make the base a little narrower, and I'm good to go. Well, not really. Let's see what happens. So, like I said, I would want to change the base. So I select the base and make this base a little narrower. I essentially reduce the width. I do this in the GUI. I have to wait a little, and then I see that the design breaks. Well, the base is moved a little. That's no problem. I can just move it back. But notice how a completely different edge is filleted here. Why is this? Why does the design break? Now, if you remember, while creating the fillet, we selected this edge here using a mouse pointer. This edge maps internally to a reference, which is edge 10 here. Now, this edge 10 reference is not robust. Now, if there is a perturbation in parameter values and there are more or fewer edges left, then there is no semantic information left or no semantic information at all to map the older edge reference to the newer set of edges. To recap, we made this original design and then we changed it. We just made the base a little narrower. We were expecting this final design, so notice how what I wanted was the cylinder to be on top of the base and all edges connecting the cylinder to the base to be filleted. So this one, this one, this one, and the one which is occluded to be filleted. This didn't happen in FreeCAD. In fact, I got something completely different. A completely different edge was filleted. Of course, at this point, you may say that, well, of course, I'm a professional and we have standards. We don't use FreeCAD. We use professional CAD software, and these softwares use very good heuristics. And you may be right, but notice for how for this simple example and this simple parameter change, we get this result in Fusion 360. Notice how the edge here and here is filleted. That is good, but this is still a wrong result because this edge here and the one on the other side, which are also the edges which connect the base to the cylinder, are not filleted. Onshape, on the other hand, completely changes the shape of the cylinder. There is this edge which is filleted, but this edge is not. At this point of time, you can already guess that this is an endemic problem with GUI. As GUI does not capture any semantic information, designs are inherently brittle. So what about programming and the promised robustness? Let's go over our code. The same code, the same design as before. We're designing a toilet paper holder. We use CAD query, and this is going to be very simple and straightforward. We first make a box with this length, width, and height. This is this here. This looks good. Remember, next we wanted to make a cylinder. This cylinder needed to be on top of the base. To do this, what we do is we start with the base and then we try to get the topmost face. This is done with this selection query here. What CAD query does is it looks at all faces of this base and it gives you the face or the faces which are maximal in the Z coordinate axis. Once we have this, we make a circle and we extrude the circle. And this gives us our cylinder. Next, we union the cylinder and the base to give you this. This is very good. Next, we wanted to select this edge here and fillet it. To do this, we need to write another selection query, and this is what it looks like. We start with the union result of the cylinder and the base, and of all the edges here, we select edges of type circle and those edges which are not maximal in the Z coordinate axis. Once we have these edges, we fillet them with this radius. And this is our final result. This is our toilet paper holder. So essentially, the run of this program gives us this. Now, if we change parameter values, so we make the width a little narrower, we do also get the correct result. I think this is the correct result, as we already saw before, because this edge, this edge, this edge, and the one on the other side, these are all filleted. These are all the edges which were connecting the base to the cylinder, and these are all fill it. Again, if you're unhappy with the result, you're free to go back and change the relevant selection query. There are no opaque heuristics at work here, and the query that you see and write in the code gives you the result that is obtained by running the program. Now, if you focus on this and this line of code here, these queries are difficult to come up with. These capture the semantics of the operations, and these are essentially what is missing in the GUI, and this is what makes designing in GUI brittle. Now, these queries that we just saw were difficult to come up with, right? Well, the problems with programming do not stop there. Let's say we run to the supermarket and have acquired ourselves quite nicely 10 rolls of toilet paper. Now, obviously, the first thing we do is print a box for it. GUI is brittle, so I download this program based design online. I want to change these circular inserts here. I zoom in, so this is essentially what I want to change. This is program based, as I already mentioned before. And well, as you can already guess, I have problems now. Which line of code would help me change this? Of course, as programs get larger and larger, designs get complicated and more complicated, it becomes quite difficult to know which line of code causes which element in the final design. And this brings me back to our system. We link GUI and programming so that each element in the GUI can be mapped back to a line of code in the program. Then, when a GUI operation is performed, the fillet here for example, we can synthesize a relevant subprogram and add it to the programmatic representation. Finally, a render of the modified program can be used for rendering the GUI. The idea seems quite grand, and of course this is linking programming and GUI. So changes in the GUI are reflected back in code and vice versa. Now, some work already exists on this theme for 2D vector graphics. Ravi Chugh and others have used constraint solving along with some heuristics to enable small program modifications using the GUI. So you change something here in the GUI and this is reflected back in the code. It's a small modification. Concepts from this prior work can already be applied to CAD in the context of rotations and translations. The focus of our work is on the synthesis of robust selection queries from GUI-based selections and operations. These are the parts, if you remember, that are difficult to come up with in programming and are the source of brittleness in GUI. At a high level, our synthesis approach is based on decision tree learning. The underlying syntax gives us some predicates. So at each step, we greedily choose the best predicate and then combine these together. As is standard, we favor the synthesis of small queries and then enumeratively build a correct by construction query. Let me give you a simple example of how this works. We wanted to fillet this edge here, right? I'm going to label all the visible edges here in this design, and these are our coordinate axes. What we do is we start with the list of all edges that could be selected, this here, and then we ask CAD query what the best predicate would be to get S1. This is the edge we wanted to select. So eliminate everything else and select S1. We see that it is type circle. We get S1 and E1 here, S1 and E1, but quite nicely this predicate eliminates every other edge. Next, we do the same. We ask what the best predicate is, and here it seems that it is maximal in the z-axis. This gives us E1 here, and quite nicely, we have S1. So our final synthesized query is type circle and not maximal z. So type circle and not maximal z. Now, there are of course other things at play, and these are all described in our paper. Before we proceed, there is one more thing worth pointing out. We track all intermediate objects. This enables us to map elements in the GUI render back to the relevant line of code. It helps us synthesize at the relevant line number and also gives context on the line of code elements are created in, so as to help with code modification. Now, without further ado, here is our technique in action. We're creating some 3D designs in GUI here. So we essentially make some selections in the GUI, and the selection query is synthesized for us. So again, we make a selection and the query is synthesized. We select this edge and this edge, and we get a robust selection query. And many of these queries are also, as you can imagine, quite difficult to come up with ourselves. So here we select this vertex here, which gives us this query, and then select that vertex there. We select this edge, get this query. This plus x means that the edge's normal is in the positive x axis. So we select this face and get that query. This all looks very nice. I'd just like to focus on one unique example taken from our case studies, and this will show you how coupling programming and GUI can give us something neither interface could offer alone. So we have a plate of braille here. The cylinders we see here were all created in a collection in the programmatic representation. Now if we select one circular edge here, so let's say this one, and we round it, what our technique can do is synthesize a query that can be applied to all of these edges. So all of these circular edges here. We don't need to select each pesky edge one by one in the GUI, nor do we need to think about the whole selection semantically and write a query for it in the code. This is very nice. You will recall this slide from the beginning of the talk. These are designs we have obtained from the internet, from the CAD query repository, and Thingiverse's customizable section. We have successfully redesigned all of these objects using our system. Let's look at some numbers now. In our experiments, we found that our technique synthesizes the exact queries programmers themselves would come up with most of the time. And if not, we produce something equivalent, meaning there is no difference between the two queries. Of course, we need to be quite fast. We're working with the GUI. In our experiments, 1/10 of a second is the longest we took to synthesize a query. This means that designers can quickly make a selection in the GUI, and a robust selection query is almost immediately synthesized for them. We found in a user study that users were faster, they were more accurate, and they preferred our technique more than plain old programming. I'd like to conclude now. We try to couple GUI and programming so as to get the best of both worlds. Our synthesis technique is successful in capturing semantics from GUI. It is also fast and scales to complicated designs. Detailed user studies remain, but our experience is quite positive. And that's it. Before I let you go, I'd like to thank the anonymous reviewers who were assigned this paper, the conference organizers, and you for listening. Please read our paper available here for more information. Our source code is open source and you can try it for yourselves here. I look forward to your questions.